The NEET 2020 question basing on a concept of friction. Let's have a look at the problem, what he's saying, right? Yeah. Calculate the acceleration of the block and trolley system shown in the diagram. You can see the diagram. Coefficient of friction is given for you, G is given for you, mass of the string is negligible, and no other frictions are existing, right? So let's try to identify what are the forces acting on each of the bodies. Here, weight 2 into gravity acts always down direction. This string becomes tight and generates a tension, and because of the pulley this is going to move down with an acceleration, and the same tension is developed here towards the point of suspension, that is pulley. As the system is moving forward, between these two the frictional force acts in opposite direction, backward, right? So what is that frictional force is equal to, we will discuss later. And this entire system is also going to move forward. So I can draw free body diagrams for each of them. Free body diagrams. 2 kilograms, say for example. Weight acting in downward direction, tension acting in upward direction, and the entire system is moving downward with an acceleration A. So I can write F resultant as the system is moving downward direction, force in downward direction is positive, upward force is negative. F resultant is MA, that is 2A. 2A equal to 2G minus T. That's one equation that I can write. That's the first equation I can write. 2A equal to 2G minus T. Then let's write a free body diagram for the other one. For the trolley. Free body diagram for the trolley. Trolley is like this, whose mass is 10 kg, attached to a string who is having a tension T. Between the wheels there is a frictional force acting in backward direction, but the system is moving forward towards the right. So I can write F resultant as tension minus frictional force. F resultant is MA, that is 10A, tension minus frictional force. Frictional force can be written like mu into normal reaction. Then its weight is in downward direction, and in perpendicular to that normal reaction acts. So here normal reaction is nothing but equal to weight mg itself, that is 10G. So 10A equal to T minus mu value is given to you as 0.05, mg is G. Though he has not given, I can assume G as 10 meter per second square because of the round figures, and we can make the calculation simple. That implies 10A becomes T minus 0.05 into 10 into G is also 10. So 10A equal to T minus, this is 100. This is 5 by 100. So it becomes automatically T minus 5. So I got two equations, that T minus 5 is 10A and this equation. And this is another equation. 2A equal to 2G means 20 minus T, equation number 1 and 2. From this 1 and 2, I am supposed to find out what is the acceleration of that system is, right? So what is the equation I can use? I can use is this in the place of this, from here I can write T as 10A plus 5. Substitute in equation number 1 and see what happens. 2A equal to 20 minus, in the place of T, 10A plus 5. So 20 minus 10A minus 5 equal to 2A. 20 minus 5 is 15 minus 10A equal to 2A. Get that 10A this side. It becomes 12. 12A equal to 15. So acceleration equal to 15 by 12. That is 3 5s and 3 4s. That's 1.25 meter per second square. Once after you getting the acceleration, though it is not asked in the problem, we can substitute in any of these equations and get the value of the tension. For example, if you need to calculate the tension can be written from this equation as 10 of 1.25 plus 5. That is 12.5 plus 5. That is 17.5 Newton. Like this, we can solve any of the part of the problem. Even you can calculate a frictional force is how much you can calculate as mu into normal reaction. Mu is 0.05, m is 10, g is also 10. So that's going to be equal to 5 Newton. These are the basic things that we can identify in solving and identifying different things in the problem. Even if we ask it to find out, if it is needed, we can do this part also, right? Thus, we have calculated acceleration by drawing free body diagrams. Just to tell you that how do you draw a free body diagram, we shall consider any body. We shall write all the forces acting on the body, never write the forces applied by the body, and see in which direction that is moving. Consider the force in the direction of motion as positive. Consider the force against the motion as negative. Similarly, here also, it's moving towards the right. So this is force acting along the direction of motion is treated as positive. Against the motion is treated as negative. Along the motion positive, against the motion negative. By writing equations and by solving them, we can just get to the answer that whatever you want. That's how we have to solve the problem. Thank you for watching.